So yeah, good day everyone. Welcome back to week 6, session 2 of testing in Starknet of GIDA Skill Up Bootcamp. And once again, I'm Weval and I'm going to be taking you on this session. And I believe yesterday we were able to discuss and learn about a lot of things about the types of tests. Let's just go over it a little bit. We went through introduction to testing, why do we test, writing basic unit tests, we wrote basic Cairo programs, and yeah, we wrote basic unit tests. We went through the anatomy of the test function, and yeah, now we're in session 2. I hope you all can hear me. If you can hear me, please leave a reaction. If you can hear me and you can see my screen. Yeah, that's perfect. So in this session, we're going to be going through Starknet Foundry, right, which is Starknet. Can you turn off your mic? Yeah, which is Starknet testing package for us, right? And we're going to do basic integration test on the counter contract. If you remember in the previous class, I said we're going to be testing a simple counter contract. And what the counter contract does is basically just counts numbers. All right. And we started writing the contract in the previous class, but I went ahead to complete the contract myself and I can share the code with you so you can test it along in class. Where do you prefer I share the code, in the live chat or on the WhatsApp group?
Share it in the WhatsApp group.
Okay, so you have to give me a minute there to do that, right? But apart from that, is there any question from the previous class that we can answer quickly before we continue? Is there any question, any challenge you faced while trying to replicate what we did? This is the time to get that answered. So since there was no question, I think I'll be asking my question. So what is the anatomy of a test function? Like a simple test function, how is it like? I need somebody to answer the question. I've shared the code on the WhatsApp group. You can just copy it. Perfect. Nobody has answered my question yet.
Sorry, sir. Can you repeat the question?
Okay, I can repeat the question. The question I asked is, can somebody tell me the anatomy of a test function? And then somebody else should differentiate between a unit test and an integration test. Before we go through what we have for today, we have quite a lot to learn today. So can somebody do that quickly before we proceed? I'm not getting any response, but then I'll leave the questions to the end of the class, right? Because of time. So if you've been able to copy the code, all right, you can just paste it directly here into your lib.cairo. Right, if you remember from the previous class, we scaffolded a new project. So if you were not able to do that in the previous class, This is the exact command you need to scaffold a new project. Just type scab new and the name of our project that we use is counter. And then we selected the test runner. The test runner, we selected Starknet Foundry, all right, by default. And yeah, that's that. So I believe you're able to do that and you have been able to scaffold your project and get up to this point. And then next thing we did, we had to remove all the default code, all the boiler code that was generated for us in the lib.cairo and also tests, in the tests contracts or in test file. So now, yeah, back to our session 2 topics. So for session 2 topics, the first thing we want to do is a little bit of introduction to Starknet Foundry. Basically, Starknet Foundry is a toolkit. I think I can just look that up right here. And yes, Starknet Foundry we can. So Starknet Foundry is a toolkit that consists of two things, all right, which is basically the SNforge and SNcast. All right. So SNforge is the testing library. All right. The SNforge is a testing library, it's a tool chain for developing Starknet smart contracts. It helps by writing, deploying, and testing. It helps with writing, deploying, and testing your smart contracts. So it consists mainly of two things: the SNforge and the SNcast. So the SNforge is what we use for testing. All right. The SNforge provides us with all the utilities we need for testing our um, smart contract. And while the SNcast provides a way, a kind of like a CLI way to interact with the Starknet blockchain from your terminal, right? Doing things like creating an account right on the Starknet blockchain. Right. So if you understood what I've been able to explain, I've differentiated between SNcast and SNforge. SNforge is your testing package, while SNcast is your is a command line tool for performing Starknet RPC calls. All right, so the RPC calls basically means for interacting with Starknet smart contract on the blockchain. Right, and for now we're going to focus on testing, right? Because that is what this week's course is about. It's about testing, and for that we're going to be using SNforge. All right, and similar to the Cairo book, we have the Starknet Foundry book, and this book basically it contains all the information you need to know about testing, right? About the Starknet Foundry package. So you can always come here. If you forget a syntax, forget a command, you can always come here and get relevant information about what you need to get your job done. All right. So that's a brief introduction to Starknet Foundry. The next thing we're going to do is basic integration tests. But okay, yeah, we are going to do the basic integration test. Then which is testing the counter contracts. All right. The basic integration test is basically testing the counter contract because we've explained what really an integration test is, right? When I explained an integration test, I basically said an integration test is a test that helps you to test your smart contract, right, by using the public interface or by using the publicly available functions, similarly to how um just it basically just tests how other contracts can interact with your contract or how users can interact with your contract. So that's how we test it, how the contract integrates well, right? So that's basically that about integration test. And for that, we're going to be testing our counter contract, which I believe you already have. So with that's enough what said. Let's jump into the code. So if we go through this right here, right, can you see my VS code? I believe you can see my VS code. Cool. So we'll just go through the code here. basically, this is a simple contract, and I believe you have been taught about most of the things here. So everything here should really be familiar to you at this point. But we'll just scan through it before we start testing it. All right. So the first thing we have the interface attribute. All right. An attribute is just like a metadata that tells the compiler that whatever is coming after this is this. Right. So it defines um a metadata that the compiler will use to undo this. So so this interface attributes, Starknet interface attribute, basically tells the compiler that whatever is coming after this is the interface, right? And for that, you use the T contract state, right? That we pass there, and then we define our functions, right? The functions parameters, which is taking the referencing the self state. And that's why it does that, is because this is a modifying function, a function that modifies the state of the contract. Why this, you can see it uses an at, all right, and it doesn't use the ref. Basically, you have been taught this, but this is just a walkthrough. This just tells that it's reading the state of the contract without making any change and returning a U64 value. So basically, we have three functions exposed. All right, you can see it's public traits, right? So this basically defines the functions that are exposed by our contract and can be interacted with. So basically, in our integration test, these are the functions we are going to test, right? These are the functions that will be available for us to test. Why? Because they are the ones that are public facing and are exposed, right? But for unit tests, on the other hand, we can test different functions, right? Private or any simple function defined in the contract or wherever, right? That's the difference between the unit tests. For the integration tests, we're basically testing the functions that are exposed, testing them separately from the contract. Why? For the unit test. And the convention in Cairo for writing unit tests is basically keeping the unit test in the same file as the functions to be tested. I think I mentioned this in the previous class. But for integration tests, your tests, all right, your tests are usually kept in a test directory. All right. So if you look at this, beside the okay, you can get rid of this, but basically this target directory is your compiled code, right? Whenever you compile your Cairo code, is going to be found in your target directory. You can see the dev, fingerprint, all these are just result of the compilation, right? We don't need that for now. Even if we delete this, whenever we recompile it, we are going to get that back. But what I'm driving at is the test folder or the test directory here. This is where all our integration tests, the convention in Cairo is to have a folder or a directory named tests. And then with that, you can have as many files as you want, right? And each file is a separate crate, right? That means it runs separately. Okay, let's say test. So you can test different modules. For example, in our contract, we don't just have a counter contract, we have several contracts, right? So the first test could be testing the first contract, the second test could be testing the second contract, and so on for as many um integration tests you want to do. Do you get? So basically we can even move this from our lib.cairo to a counter.cairo. We're doing it just because we can, not because it's necessary. We can always leave that there. And then we paste this here. So, but if you do this and you leave your lib.cairo empty, the build is not going to include that. The build is not going to include that. Why? Because it's empty. Your lib.cairo is empty. The build is not going to include this counter.cairo. Now, if you observe something, directories back, and that's because the contract has been compiled. So to expose this module, right, this counter contract, to expose this, we have to expose this file right here. And we do that by saying pub mode counter, right? So this is a module, and so basically this just tells the compiler that when it comes into this, when it's for this lib.cairo basically is a crate, right? I don't know if you've explained this. So the separate crate, a crate is basically a a a package, right, that contains a body of all the code related. So basically the lib.cairo is a crate that contains, the convention is to put all your related codes are in your lib.cairo. So when the compiler tries to run your code, it sees, it goes through this and sees this pub, makes it exposes the file for other files to be able to access it, and then it says the module and then the counter. So this right here just tells the compiler that you should look for a counter module in the source direct in the source what do you call it, in the source folder. That's basically what it does. Right. So now inside the counter file, all these, your traits, your contract, the interface and the contract are now made public also. So they are also exposed. So when we want to access the contract or the interface of the contract, we can simply just say counter, we can access the counter module and access the counter contract. We understand that when we are trying to get the counter contract in the test file. But basically, I was just trying to explain the file system in Cairo a little bit. So that's that. Now we can build this again, and this time it will include the counter contract in the build. You can see it's throwing an error. It's throwing, so the contract is throwing an error, and if you see this, it's saying identifier not found, right? When we try to build the contract, and what it's saying use OpenZeppelin access component is not available. And yes, we are getting that error. If you try that on your end too, you're supposed to get that error. And why is that? Okay, I was explaining the contract, so I think I'll continue there before we import OpenZeppelin, so we can get straight into testing without wasting further time. If you are still following, please just leave a reaction in the chat. Right. So yes, we've explained the interface, right? Next, we are explaining how the contract works. So for the name of the contract is counter, and it is the convention to name the interface and the contract the same name, just include an I for the interface. Now we are using OpenZeppelin. OpenZeppelin is a library of code that has been vetted. It has passed through. OpenZeppelin is a big company, Web3, that helps in making different reusable components that have been tested properly. So we are going to be using their Ownable component. Basically, this is their Ownable component, helps us to, if we have been taught about components, right? Component is reusable code that we can always make use of. It's not a standalone contract, but it's a reusable code that we can always use to get particular features in our contracts, right? So the ownable component basically just allows us to perform some things like the specifying the owner of the contract, right, which will now give the, which will be used in like as asserting access control, so that only the owner will be able to do some things, and if it's not the owner, it will not allow them to perform some functions. So that's basically what we're using the OpenZeppelin for. then it's using Starknet's contract address type, and it's using the storage pointer access and storage pointer write access. Now, if you remember when we were talking about components, you have to define the component parts, the storage, and the component event. Then you also have to embed the functions, right? Whenever you see ABI embed, it basically means these functions are going to be exposed by the contract. So it's going to expose some functions that the ownable component provides to us. Some functions like owner of, I think so. I can't really remember those. But then if you deploy your contract, you're going to see some of these components. And if you go into the code, we'll see that, but we're not worried about that for now. And then these are also internal implementations of the contract. These ones are going to be exposed. Then we have our storage, which is storing the counter, AU64, and then the ownable component is added to the storage also. And then in our constructor, it takes two parameters, the initial counter and then the owner. So now this owner of is going to be passed to the ownable component as the owner of the contract, right? And then we write the initial counter as the first state of the counter, which we are going to start at 0. All right. Then these are events that we are going to release. Whenever the counter is increased, we'll release the counter, the current counter value. And whenever the counter is decreased, we release current counter value. Then we have a simple function that increases the counter. First thing it does, it asserts that only the owner can call this function. So whenever a person that is not the owner of this contract calls this function, is going to throw an error that caller not owner, right? That the caller of the contract is not the owner. And then we have a simple assert that makes sure that the amount we're passing to the contract is not 0. Else it will throw this error, which is amount cannot be what 0. And I remember we talked about asserts a lot yesterday, so you can see how it's used in this function right here. And one simple thing to note, if you see this particular assert, it has an exclamation mark, right? While the other doesn't. If you observe that, yes, you can ask your question quickly. I will
Okay,
continue.
sorry for interrupting. In this
Yes,
assert, the amount
yes,
that you see less than, why don't we use assert else, that is assert less than? Why do we use assert assertion, the
yes.
actual assert
You
macros?
can you Yes, thank you for the question. So you can choose to use whichever you want, but personally, I love to use the assert, then do the comparison myself. You can use that to give you the same results, right? You can use that. But one thing I was about to explain is that if you look at this has an exclamation mark and this doesn't, right? This is using single colon and this is using double colon. I don't even remember if that's called colon or whatever. But you can see the difference in these two. Now, what makes that difference is this is basically an assert function provided by Cairo, right? And this is an assert macro. So there are two different things, right? This is an assert function by Cairo. This is an assert macro, right? There's an assert macro package that in some cases you have to install, but I think in our case, it just comes with Cairo at this point. But before you usually have to install the assert macro package. But that's basic difference. This is a simple assert function, right? And this is an assert macro. You see, a macro basically provides several functions. The assert macro provides the assert early, assert GE, assert EQ, right? That's the macro. And to use the macro, you must pass a byte array. So you need if you don't know this, you encounter errors and you will not be able to figure out why. So the byte array is a double string, right? So to use the macro, whenever you're using the macro with exclamation mark, whether for assert early, assert GT or whatever, you must use it with what? Double string. While if you are using the assert function, it only takes a field 252. So you must use it with what? a single string, and your value that you're passing here must not be greater than, I think, 27 or 21 characters for field 252. Right. So that's basically the difference between the both of them. I think I was able to explain that. Right. So the first thing it asserts that the amount we're passing is not zero, else it will throw this error of L252, the amount cannot be zero. And next, it will ensure that the amount is greater than what? Zero. So basically these two comparison this is to prevent us passing zero, and this is to prevent us passing anything less than zero, right? So when you're increasing the counter, you cannot decrease the count, you cannot increase the counter. This is just a silly assertion, but it's to ensure that the amount is greater than zero. Amount cannot be less than zero. I don't really think we need this assertion, right? But we'll come to that later. Then we write the counter that safe.counter.write, then increase the counter, the current value of the counter, increase it by 1, then emit the event counter increase and the current counter. Then the get counter just basically returns the value of the counter. Then decrease counter also asserts that only the owner calls this contract, and then it reads the counter. It asserts that the counter, the value of the counter is greater than zero, right? So else it say counter cannot be less than zero. This to ensure that we cannot decrease the counter less than zero, right? And the next assertion is to assert that the value of the counter is greater than the amount you want to decrease it. So you cannot decrease the counter less than you cannot decrease the counter less than it is, right? And then you write to the counter, subtract the amount, and then you emit the counter decrease event, right? Let me just go through the logic. I believe we have been able to understand that. So this basically says outside that the amount is not zero, so you cannot increase the count by zero, and also assert that the amount is greater than zero. Okay. Yes, so you cannot pass zero. Okay, the amount cannot be less than zero. Let me just leave that. Then this is asserting that we cannot decrease less than zero, and we cannot decrease less than the counter. Okay. Yes, because why I'm doing that is because these constraints provided by our functions are going to play a role when we are testing them, right? So when we are testing them, we want to test these constraints. So that's why you need to understand the code. So basically, if you remember when we tried to run scap build the previous time, right, we're getting this error, identifier not found. And why is that? Is because we have not added the OpenZeppelin package to our project right here. So to do that, I can just copy the name of the package here. You can do that also and go to the scarp.toml and add it as a dependency, right? You add it as a dependency, and we'll use the version 2.0, 2.0.0, right? Once you do that, I think we should be able to get rid of that error that we're getting. So we can run scarp build again, and it should work properly. Now you can see finish dev profile 7 seconds, right? So you can get rid of that. So you should not be getting that error. So yeah, you can see the assert macro pack dependency that I was talking about, right? This is what gives us the assert with exclamation mark, right? So when you do scab new, I think it's scaffolds the SNforge, and the assert macro package for you by default, right? So with that, you can start using the assert macros, basically. So that's that. I believe we're able to follow up to this point. The scarp.lock is just like your package lock.json if you've written with npm, right? You don't need to edit this. So now we can decide to name our test file or whatever name we want. All right. So I'll rename this to test contract. Where is the rename again? Okay. I'll rename this to test counter just because, right? So now this is where we'll get into the actual testing, right? And I need you to follow along. Have you been able to follow along up to this point? I need your response in the chat. All right. So we're about to start the real testing now. So if you remember when we're talking about the anatomy of the test, there are three things we're going to do, right? We're going to do the what? Set up the, let me go back to it. We're going to do the setup. We're going to run the code that we are testing, and then we are doing the assertions. So first of all, we're going to start with the setup, right? And to set up, what we're going to do, we're going to need to declare the contract and deploy the contract. If you remember in your introduction to smart contract on Starknet, you have to declare the contract before you can deploy the contract, right? And declaring just creates an instance, um declaring publish it, the contract, right, on the blockchain, and declare and deploying creates an instance of that class hash, right? I'm sure that this should not be new to you at this point. So that's basically what we have to do to set up the contract for us to be able to work with that contract. All right. So for that, we're going to create a function that deploys the contract. And before we do that, we are going to import some things from the SNforge standard library. If you look at your scarp.toml, this is the SNforge library, SNforge std. That's the SNforge standard library. So we use the use keyword in Cairo to import, and then we have to import some important traits. The first thing we're importing is contract class trait, declare results traits. All right. Then, yeah, I think we'll keep it at that for now. Right. So these traits are going to be important for us to declare and deploy our contract. Then another thing we're going to import is the contract address type from Starknet. Then, yeah, we can write our function that deploys the counter contract. Whatever we choose to name it, whether deploy counter or deploy contract, is our decision. So basically, the function is going to deploy our contract simply. And if you remember, to deploy a contract, there's something you must do. The constructor function is called only once, right, during deployment. So we have to pass these parameters, the initial counter and the owner parameter during deployment, right? So we need those values. But the first thing we're going to do, let's class hash. We're going to get the class hash by calling the declare function, which is provided by SNforge SNforge library, right? And the name of our contract right here is counter. You can see it. That's the name of our contract right here. Right. So we'll pass the name of the contract, call the declare function on the contract, then unwrap whatever is the result that is returned, and call the contract class function on it to get the contract class hash, right? So this is the first step in declaring the contract, right? Then the next thing we have to do, we have to deploy the contract. Now deploying the contract returns a tuple. I believe we have gone through the tuple data type. Basically, two values, the contract address and I think an error, if an error occurs. I don't really remember, but we don't really need that value. So that's why I'm using the underscore, right? Underscore underline. I think it's underscore. So that's why we're using the underscore. Basically, it's just an empty variable name, basically. So now to deploy the contract, we have to deploy the class hash. So the class hash has a method. So the what we name the class hash here, this is where we got the class hash, right? So you have to do class hash dot deploy, call the deploy method on the class hash, and then pass our call data, right? Which is our call data when we want to deploy is the constructor call data. This is called these values that are passed to the constructor are called the constructor call data. So the two values we need is the initial counter, which is U64, and the owner, which is the contract address, right? And then when we deploy, we want to unwrap that also, unwrap the results. And when we unwrap it, it's going to be a tuple. And that tuple will destructure it. We'll destructure that tuple to get the contract address, right? So basically, this is how we deploy the contract. And then one last thing we're going to do, we want this, we want that whenever we call the deploy contract function, it returns something. It returns the contract address. So we're going to pass the type of the value that's going to return, which is contract address that we imported here. And what is going to return is this contract address value here. So we can either choose to say return contract address like this, or we can just do this. Just write the contract address without a semicolon at the end, and Cairo automatically knows to return that. But now what we have not done right now is we have not yet passed the constructor call data. So that's what we're going to do. Now, to be able to pass the constructor call data, we have to pass an array. All right. The deploy function expects an array. All right. And we're passing the array of our call data. So the first thing we need to do, we need to create an array because that's what is going to be passed to our deploy function. All right. So we can name that call data. Right. And then we can use this array shortcut to create an array. All right. Are we following? Because this is the call data array that is going to the deploy function expects a call data array. All right. Expects an array. And that's what we're going to be passing here. All right. And it's called data. So, and what values are we going to pass to the call data? For our particular constructor function, we are expecting the initial counter and the owner. Right. So we can define variables of initial counter, right, which is what a U64 type, and we can just keep it as 0. And then the owner, we expect the contract address, right? But what we can do right now, one of the best practices that we do a lot is to create a function that basically gives us a contract address. How we do that, we just create a simple function with the name of the address, right? Let's say owner, that will be the name of the function, and then it should return a what contract address. They will define the function. What we can simply do here is just pass a simple file 252 of whatever value, right? Whatever value you pass in your 252 file 252, and do try into, we call the try into function, and then unwrap the result. It is going to return this line of code here is going to return the contract address. Why? The try into function basically just tries to convert this field 252 to what the expected return value is, which is the contract address. All right. And when it does that, the result, we still need to unwrap that result to get the each actual value inside of that result. Do you understand what we're trying to do? So whatever field 252 we pass here is going to be used to generate a kind of, let me not say random, but it's going to use to generate a corresponding contract address, right? That we're going to be using to deploy our contract. So we can simply keep this as owner just to match the convention of owner. We use the owner field 252. We can have as many functions to create contract address. I can name this whoever, right? And returns the contract address, and you can do this whoever dot try into dot unwrap. I'm trying my best to explain every single step. So basically this returns a simple contract address. So now when we are passing the value to the call data array, we can simply just call the function. So when we call the owner function, right, it returns the generated contract address, right? But now what we want to do, we want to pass this data. Now, if you look at this is U64, and this is the contract address. We want to pass those data into the array, and to do that, we have to serialize it. Serialization is basically just converting the data type into the corresponding, I think, byte code or so. So that's what is going to be passed into the array, right? But basically, serializing is we just want to serialize it the array, into the array that we created. So to do that, we can just say initial counter, which is the value of 0 here, and we're going to call the serialize method, and then pass it into the call data array. So we're passing the ref because we're going to modify the data in the call, the value of the call data, right? And also we can serialize. So we have to pass the initial counter first, because if you see what the constructor expects, the initial counter and the owner next. So we're passing the initial counter, serialize it into the call data, then the owner function, which is going to return the contract address, and we serialize it into the call data also. But if we do this, this is going to give us an error. Why? Because by default, all right, this array is not, you cannot just change the value of an array. The array data type, the number of items in the array data types is fixed, all right? So you cannot just mutate, all right? You cannot just mutate the values inside this array, right? If you understand what I'm trying to say. So what we have to do, we have to pass the mute keyword. This will allow us to be able to mutate the values or to add things into the array. All right. So if you don't have this mute keyword here, you'll be getting an error because you cannot just pass or serialize this into the array. All right. So with this now, we have our function that deploys the contract. So whenever we call this function, it declares the contract, returns the class hash, serializes the constructor call data, right? And serializes the owner also. And then, okay, the last one we want to do, we want to pass the call data into the deploy function, right? Because that's what the deploy function expects. You expect an array of the call data. So we're passing that. But what we want to do, we want to pass a snapshot of that. So when you use the at basically just says you're passing a snapshot. And with this, we have our function that deploys the contract, right? Now, I think we're done with the setup, all right? So the first thing is the setup, then we do the test and do assertions, right? For our tests. So we have that setup. So what is the first thing we want to test? Right. So the first thing we can decide to test, we can decide to write our first test, right? And to do that, the first thing we have to do is what? To add the tests attribute to the function, right? If you see here, we didn't add the test attribute. Why? Because this is not a test. This is a utility function that deploys the contract. This is also a utility function that returns a contract address. Now, but when you mark a function, yes, you can go ahead with your question.
Okay, please, can you tell me the difference between the utility function and components?
Okay, basically, a utility function, the word utility, you just utilize it for something. It has a specific use that you can easily reuse that function, right? So you basically create a function that does a particular thing, right? And now a component is basically, it basically has the same idea as a reusable function, right? But then a component can be passed from one contract. All right, a component is defined in one place and you can use it in any single contract. All right, this is not a component. This is just a simple function and is only available inside this file, right? Except to export it or make it public for another file. But a component, you can use it in as many contracts as you like. Like, for example, you can see this component here that we imported. It is not part of our code base at all, but we're able to use it as a part of our um what do you call it, contract. And also another thing that differentiates just a utility function from a component has access to storage. It has access to the state of our contract. It has ability to emit events. All right, this cannot emit events. This doesn't have access to the contract. All right, this is just basically a simple function. Do you understand that? So a component is almost like a contract of its own, just that it cannot be deployed on its own. Right? A component is almost like a contract, but cannot be deployed on its own. This is just a simple function. So basically, that should answer your question. And now, where we stopped, I was telling you that this is not a test. So to identify a test, it must have this test attribute above it, right? That basically tells this compiler that this code should only be run whenever we run scab tests, all right? So whenever you mark a function as test, it will not be added to the build, all right? So when you're building the final contract, whatever function you mark as test will not be added to the contract. Why? Because the compiler basically knows that this is not part, this doesn't have any effect in running the contract, right? This is just used for testing. So the tests or any function marked as test is not going to be added to the build of the contract. Do you understand that? But it's going to be run only when you are running tests, only when you do scap test or SNforge test, that those functions will be run. So we can write our first test, and it's just a simple test to test the initial value of the counter. Now, basically, we expect the initial value of the counter to be what? To be 0, right? Because we are deploying the counter with the state of 0, right? So we can write a test that ensures that when we are after deploying the counter, the initial value of the counter should be what? 0. So to do that, we can just call the deploy contract function, right? Which we have defined earlier. And this function is going to return what? It's going to return the contract address value. So we can store that in a let. So let's say contract address, right? And that's going to be the value that is returned from deploy contract function, right? Now, when we deploy the contract, we get the contract address. Now, the next concept we are going to be introduced to is the concept of dispatchers, right? I know we've not talked about that before, but this is where we're going to use dispatchers. Now, basically, to be able to call the functions in this contract, right? You see, they are exposed in the traits, right? Remember when we exposed these functions in the traits, like increase counter, decrease counter, get counter, and we talked about integration tests. We said integration test is a test that has access to the public functions or to the functions exposed. So to be able to perform the integration tests we're going to perform are going to make use of these functions exposed here. Now, for us to be able to use those functions, we need something called a dispatcher. All right. Basically, what this does, it just basically deploys the contract. We don't have access to the functions in the contract. We just have the contract address, right? It basically just gives us the contract address. It doesn't give us the contract itself. Do you understand? So this just deploys the contract and gives us the contract address. It doesn't give us access to the contract. So to be able to call functions on that contract, we need something called the dispatcher. And anytime you define an interface, all right, the compiler automatically would generate a dispatcher for that interface. All right. And that dispatcher is basically, it provides the types of what you can pass into the function. The dispatcher contains the methods that can be called on the contract, which is increase, counter, this, the return values. All right. So the dispatcher basically is like a replica of this interface. All right. It gives access to the contract interface and allows you to be able to actually call the contract. All right. So to do that, we have to import that dispatcher that is get from this contract right here. So to do that, we have to use keywords, right? And this is now where we now have to get to this eye counter trait that is here. So to do that, we're going to use the absolute part, right? And to do that, the first thing we're going to pass is the name of our package, which is the counter, right? If you come here, you see the name of your package name, which is counter, right? Then, as I was explaining in the beginning, I was talking about the package and the crate, right? So for every Cairo package, there's one crate that is so there's one crate that is exposed to the compiler, which is in the lib.cairo. So the lib.cairo exposes one crate, right? And this is the package, this is the crate, this lib.cairo. So now whatever module we specify inside the lib.cairo is now a part of the crate. So where we have the counter module. So to access that, we have the counter, which is the name of the package. It exposes whatever is inside this. So the next thing we have is the module. So when we are trying to access the values, we have gotten the name of the package. The next thing we are going to get is the name of the particular module we are looking for inside the package, right? Which is the counter module. And this basically tells the compiler to look for a file named counter.cairo inside the source directory. Do you understand that? So inside this file now, which is the module, which is the counter module, right? Inside this file, we now have the I counter and the I counter traits and the counter module being exposed. I believe we understand that. So to access that, we can now do I counter, right? But now we want to import more than one value. So we want the counter contract, which is this right here. Now, if you don't specify this as public here, you will not be able to access it. You'll be getting an error. So you have to specify this as public for Cairo to know that yes, because in Cairo the modules are private by default, right? So you have to specifically, you have to manually define the module as public for it to be able to access the counter. So we want it to have the counter exposed, we want to have the I counter also exposed. But I said something. I said whenever you define a an interface, right, the compiler automatically generates the dispatcher for you. And the convention is just write the name of the interface and add dispatcher to it. So we already have this dispatcher. The name of the interface is iCounter, and then we add dispatcher at the end of the name of the interface. So we have this, and we have the iCounter dispatcher. The next thing we want to import is the iCounter dispatcher trait. iCounter dispatcher trait. All right. So the trait is basically like the type, right? It has the information about the data types, right? And then the iCounter dispatcher is actually what we need that gives us access to all the functions, right? So I think with that we have been able to import from the counter module, we have been able to import the counter contract and the dispatcher that we need. So back to our first test, right? So this displays the contract. Next thing we want to do, want to get the contract itself. This displays the contract and returns the contract address, right? We want to get the contract so we can work on that contract. So to do that, we will call the dispatcher. What's the name of our dispatcher here? iCounter dispatcher. And now a dispatcher, any dispatcher basically expects a value, and that value is the contract address. So the deployed contract address that we deployed here, we're going to pass it as a value to the dispatcher. Yeah, you can ask your question.
So please can you explain that dispatcher? I don't get the meaning behind dispatcher. Please can you
Okay,
just explain
you
what
don't
it is?
understand the dispatcher, right? So basically, you get the hang of it when we write the code, right, and when we use it for the first time, for example. But basically, what I'm trying to say about dispatcher, right, the dispatcher is automatically generated for every interface, right? Whenever you define any interface with the trait, right, of a contract, the compiler automatically generates the dispatcher for you. And what that dispatcher contains, the dispatcher contains all the functions exposed by that contract and the data types they expect, the values they return, right? So that's what the dispatcher contains. Now that dispatcher gives us the ability to call the methods of that contract. So without the dispatcher, we cannot call the increase counter function. We cannot call all those functions, right? Because when we deploy the contract here, we are only getting the contract address. We're not getting the contract itself. Because to get the contract itself, we need access to the what dispatcher. Now, when you pass the deployed contract address to the dispatcher, all right, it returns a value, and that value is what is the contract itself. All right, so we are going to keep that inside the contract. So this itself is a counter contract. We can name it counter contract or whatever we want to name it. All right, so you keep this as counter. So to use the contract now, we did the first step of this test, right? So when we're talking about the anatomy of the tape, we did the setup, right? This is part of the setup, which involves deploying the contract. So we wrote a utility function that does all the passing of the call data and deploying the function. Then now we are getting the contract itself, which is part of the setup. And to do that, we have to pass the contract address to the dispatcher that we got. We got the dispatcher from the module, right? The iCounter module, right? And then we pass the contract address that we deployed to the dispatcher, and then it returns the contract itself. Now, this is what we are going to be working with the contract itself. So what our first test basically does, it basically asserts, right? It's a simple assertion that asserts that the initial counter is 0. And to do that, we have to get the initial counter. And there's a function that is exposed for us, right? Which is the get counter function. So we're going to call that function in the contract and assert that, and use the assert macro and assert that counter contract, right? Dot. Now we can call the method get counter, right? Is equals to what? 0. Right? This is our first test. This is a simple assertion. And this is the Boolean, as I explained. I believe you should remember that. So it basically calls the counter contract and calls the get counter method, right, which returns the U64 of the counter value. And if you remember, during our setup, we deployed the contract with what? We deployed the contract with a value, right, which is a U64 value of 0. So we are expecting to see 0. All right. So we can run this test and we can also add our error. All right. We can add an error if the counter is not 0. So we can say initial counter not 0. And then we can go ahead to run our first test. Let's see, cab test. So basically, when we run cab test, it's going to try to run unit tests and integration tests together. But if you remember, but in this our package, there's no unit tests. All we have is integration tests inside the test folder. So it's going to look for the test folder and run every single test file it finds. And inside the test file, it's going to run what? It's going to run the every single test it finds. But we're getting an error here. It says function not found, missing token. Okay, yes. When we're importing when we're importing those traits, we didn't add the semicolon here, so that's why it's throwing that error. I'll fix that. When we're importing the dispatcher, we didn't add the semicolon, fixed also. So yeah, don't forget to do that. Now we have to make this function public also. So because those traits were not imported, we are getting this error, identifier not found. So let's check that we have a variable named call data. Call data. So let's try running it again. Def argument must be a variable. Okay, I see the error now. Nobody was looking out for me. So I added an underscore here. All right, so that's a string that of identifier not found. Function not found. Okay, so yeah, we have to import the declare function from SNforge library. That's why we're not getting that. So we imported the declare result trait, right? This trait is what allows us to be able to use the unwrap and the methods of the declare function, but we failed to import the declare function itself. We imported the trait, right? The trait is what contained the contract class method, and we imported and gives us this the contract class trait is what also gives us this deploy method. So I think we can try that again. It's compiling, and yeah, so you can see behind the scene, whenever we run scap test, right, because of this script right here in our scap.tom, because of this script, whenever we run scap test, the scap package looks for this script named test and runs SNforge test behind the scenes. Right, so it's basically using SNforge, the Starknet Foundry package. Right, so that's what it does. So then it's looking for unit tests. You can see it's compiling unit tests, but there's no unit test. Then it tries to compile what's integration tests. And the integration test is expecting to find them inside the tests folder. Right, unused imports. We have not used the counter contract that we imported. It compiles, so if there's an error in your test functions itself, is going to the test is not going to even start running, right? So your functions have to actually even be correct. You can see we're getting errors. So the tests were not even running, we're just getting errors because our function had an error. So next you can see collected one test from counter package, running one test from the test folder, and you can see it's a counter integration test. So it automatically knows an integration test because it's in this test folder, and it says the name of the test file, test counter, and the name of the test function itself, test initial counter, and the estimated gas to use L1 data gas. So running zero tests from source folder, right? So the tests that are supposed to be found in the source folder are the unit tests, but because there's no unit test, that's why I'm saying running zero tests, and then you can see test one passed, zero failed, and so on. Right, so our first test has passed successfully. So if we do this, if we try to change the initial count, this test will fail. Why? Because the initial count will no longer be zero. So we expect that test to fail now. It's recompiling. Now you can see test fail, and it's failing with our failure data, initial count, not zero. So this is how we've written our first integration test. I hope we understood up to this point. Can somebody leave a reaction? If you have any question, you can ask. So to write our first test, we follow the anatomy of the test, which involves setting up the test, setting up the data and the environment we needed to run the contract. Next, we did assertion. All right. So we did a simple assertion to test that the initial counter is correct. So we can also go ahead to test different functions exposed by the contract, which is increase counter. So we can write another test for that. And to do that, we are basically writing a simple Cairo function, but to identify it as a test, we must pass the test attribute. Then we can give a name to our test, test increase counter, right? Write the function test increase counter. And then once again, we have to deploy the contract, and it will return the contract address, right? So you can save that inside the contract address variable, deploy contract, call that function, and then we need to get the contract itself also. So we have to call the dispatcher again and pass it with the deployed contract address. All right, so now we have the contract itself. So now we can now call methods on the contract. Now, if you come back here, you see something. You see now the increase counter expects one parameter, right, which is the amount. So if we're calling that function, let's say contract dot increase counter, we have to pass the amount or the value we want to increase the counter with. Let's say we're increasing the counter by 2. Yeah, you can ask a question. We don't have much time anymore, so
Okay. So last question. This your second function. Why is it not like inside the first test that you did? Why do you create a separate test for it?
okay, the deploy function, right?
Yes.
I talk, so I talked about this before. I don't know, maybe when you listen. I said it doesn't have a test attribute because the deploy function is not a test. Right? It's a
No, no,
function that uses the SNforge library to deploy the
no,
contract.
not
So
the
it's
deploy
not a
function,
test.
not
What
the
is
the
that?
second test did. This second one now. This function S
Yes,
increase count. Why didn't you just
yes.
like put it inside the first one? Or you are just doing it
Okay,
separately?
yes, we can do that. We can choose to do that, but then we lose the ability to separate each test, right? Now, if I do all of that inside one function, when I'm running a test for initial counter, how will I know that we're also increasing the counter also? Right. So we want to separate each test to as many functions, right? So each test is a function. So you can have as many functions as you like testing different things, right? They don't have to be inside the same function, right? So you can write as many tests as you like, but they should test different things and should give particular errors to keep the test modular enough. So you're not just packing a bunch of different tests inside one function. So that's really why we do this. Right. So do you understand? So calling this now will basically increase the counter, right? But if we do this, we expect this to throw an error. Why is that? I know you might not come to your mind. Let me just try running scap test. So basically, why that is because you can see it's throwing an error of what caller is not what the owner. Caller is not the owner. And why is it throwing that failure data? Is because when we're defining our contract, we use the ownable component, right? And we added an assertion from the ownable component that asserts that only the owner of the contract can call the contract, can call this function, right? And when we did that, we passed the owner during the construction. So if we come back here to when we're deploying the contract, you can see that we passed the owner, right? Which is this function that returns the contract address. We passed it. So only this contract address of owner can call the increase counter, can increase the counter function. For the get counter, anybody can call that function. Why? Because we did not add any assertion for that. So now we have to do something called cheating the contract. So SNforge library provides something called cheat codes, right? I know I'm introducing a lot of new concepts, but then you understand it one by one. So the SNforge library provides what is called cheat codes. Now, cheat codes are just functions or are functions provided by the SNforge library to help us cheat our contract. When I say cheat our contract, I mean, for example, we can cheat the contract address that is calling a function. We can cheat the block hash. I think so. We can cheat the particular block that is calling the contract. We can cheat the time. I think so. Those might not be the name itself, but um if you go to the SNforge website, I think SNforge book or Starknet Foundry book or whatever, like we did before, right? If you go there, you will find all different cheat codes, right? But in this class, we're going to be using a cheat code that is for cheating the caller address, right? So we'll just import it from the SNforge library. So we import two functions to cheat, which is the start cheat caller address and stop cheat caller address. I think I can run scab format. Okay, so when you run scab format, like I said before, you just format your code, right, properly for you. So I imported two cheat codes, right, for cheating caller address and for stopping your cheats. So basically, to use that, what it basically does, you just write start cheat caller address, and it's a function that you have to pass the contract you want to cheat, all right, and the caller address that you want to cheat it with. So the contract you want to cheat, we are passing the contract address of that contract, which is right here. We're passing that, and we're passing the address we want to cheat the contract as. I know it might sound strange if you have not witnessed this concept before, but you understand it soon. So I basically just pass the owner function, right? Because the owner function is going to return the contract address we generated from there. So what this does, then we're going to do the next thing, which is stop cheat caller address, and then we just pass the contract address we want to stop cheating. Right. So basically, what this does, it starts from this particular line, and every code under this line, right, is going to call this whatever code or whatever function is going to call it using this contract address of the owner. All right. So basically, normally the contract address that's calling it is not the owner, not the owner contract address that's calling it. Right. But with this cheating, with this cheat code, we can simulate an environment where it is this owner address that is calling the contract function, right? So wherever we now write stop cheat caller address, every other code, if we now do that and try to call this again, right? You try to call this again, this will go back to the random contract address that was calling, or that was calling the function. Do you understand? So it's only the block of code that is inside this start cheat caller and stop cheat caller that is going to be cheated with this address, right? So if you come back here, this is still going to throw an error of caller is not owner. But when we do this, we don't expect to see that error. Why? Because now the caller is the owner. It basically just calls this contract as posing as the owner. I believe that my explanation is solid. If you don't understand, you can ask. So if I run scab test again, I'm not expecting to see an error. Right? So the two tests are passing. The two tests are passing. Why? Because now it's calling that function as the owner. Right? If you don't understand that. So, but if you notice something, this our test is not complete. We just deploy the contract, then we call a function that just increases the counter. We are not testing anything. So according to the anatomy of the test, we need one more thing, right? And that is an assertion. So we want to assert something that when we want to assert that when we increase the counter by 2, the value of the counter is going to be what? 2. So once again, we're going to call the contract dot get counter method, right? And we're going to compare it that. So in fact, let me use another assert macro. Let me use assert EQ. All right. So assert EQ expects the first value which we are going to get from the counter. And when we increase it by 2, the counter is going to become 2, right? So the counter is going to be 2, which is the first value. The second value we want to compare it with is 2. So it's going to assert that 2 is equal to 2. Else it's going to throw the error that we define here. All right. So now what we can do, according to part of our session for today, we're already doing testing counter contract. So I'm going to be introducing this advanced concept while we write the tests. since we don't have much time. So what we're going to do now is custom failure messages, right? We're going to write a custom failure message for this, right? So what we can do with this, we can say we can get values from what was passed. Now we don't know what this contract.get counter is going to give us, right? We don't know what it's going to give us. So instead of just asserting that this is this, or else we throw a random error, we want to assert that this is this, that's 2, that when we get the counter is going to be 2, or else we want to display whatever we got from this. So let me just even write the code. So part of the error message, we can just write expected, we're expecting to get, okay, expecting to get true, right? Expected counter equals to 2, right? Found. So now we want to return, want to display the value that was found from the get count, from calling the get counter method, right? So found. Now what we can do, we can just add a curly braces here. Now in Cairo, this is how you pass variable into the custom message. So now once you've done this, all you just have to do is add whatever value you want to pass into this placeholder. You are going to pass it as the next parameter to the assert function. Right? By the time we write this like 1 or 2 times, you're going to understand it. So what we want to pass here, we want to pass the value that we get from calling contract.getCounter. So whenever we call contract.getCounter, it returns the value, right? So if it's not equals to 2, it's going to throw an error of expected the counter to be 2, but found whatever value. So that's contract.getCounter, call that function. So when it calls this, it's going to pass that value that is getting here and pass it here. So we're expecting to see found 2 or found whatever value. But now, if we run this test, we're not expecting an error. Why? Because this comparison is perfect. So let's try running the test again with the assertion. And we don't expect to see any error. So you can see 2 tests are passing, test initial counter and test increase counter. The 2 tests are passing, right? So for us to get an error, let's try to change the increase count, or even further, let's do something even funnier, right? Let's go back to our code itself. And instead of increasing just by the amount, let's add another value. Let's increase it +1. So our test will start failing. This increase counter test will fail. Now let's run this test again. You can see it has compiled successfully, and you can see running collected 2 tests, running 2 tests, but 1 test has failed, which is test increase counter. And you can see assertion contract.get counter failed. So it's even giving us a detailed information, and this is the failure data, right? Expected counter equals to, this is what we wrote here. Expected counter equals to 2, but found 3, right? It says found what? 3. So, and that value of 3, we are getting it from this contract.get counter. Do we understand? Right, so we have covered 2 important concepts now. I've covered cheat code and passing custom error message. Right, were we following? I'm not getting any response in the chat. Is there anybody still here? So I've been able to explain 2 concepts, right? The concept of passing custom error message just by adding curly braces and adding whatever data you want to pass, add it as the next parameter. Right? Add it as the next parameter. And we also covered using cheat codes to cheat the caller address. Right? So now we can go back to our code and remove the bug we introduced by ourselves. And if we run the test again, we expect the test to pass. So okay, we expect the test to pass. And here the tests are passing now. So now we have 2 tests now. So we can go ahead to write another test that tests the decrease function, right? To test decrease counter. So the same process. So instead of just writing it, you can just copy this and have it here. So we deploy the contract again. We pass the contract address to the dispatcher. So the dispatcher exposes the contract and all its functions. So with that, we can now call the contract function again. Contract dot, the function we want to call is what? Decrease counter. And when we call this, want to the function expects a value of what? It expects a parameter, which is the amount, right? And it expects a what? A value, U64. So if you pass this decrease counter of 2, it's going to throw an error. And what's the first error that is going to throw? Who can guess the first error is going to throw? Quickly. Can anybody guess this error is going to throw?
Is it owner something? Like
Yeah, caller is
call
not what? Caller is not
owner.
owner. That's the error it's going to throw. So let's just try running it. So you can see it's saying caller is not owner. That's the error it's throwing, right? Now we can do a little something, right? We can undo this error, caller is not owner, using should panic and allow our test to pass. But for this use case, well, that's not what we're trying to do here. So we'll go ahead and fix that by doing what? By cheating the contract again. So all we have to do, start cheat caller address and pass the contract we want to cheat. We pass the address of the contract, which we have here, contract address, and what we want to the address we want to cheat the caller as, right? So who we want to cheat the caller? Who do we want to pose as? If I pose as whoever, right, it's going to use whoever's address to call the contract, right? So I can stop cheat caller and pass the contract address that was. So the reason why we have to pass the caller address is because we can cheat as many contracts. So we have to specify the particular contract that we are cheating. So if we run this again, it's still going to fail. Yes, it's still going to fail. Why? Because we are cheating the contract as whoever, right? Missing semicolon. Okay, my bad. It's still going to fail. Why? Because we are cheating the contract as whoever, not as owner. So we have to cheat the contract as owner. Else, it will keep saying the caller is not the owner. Why? Because in our contract, we strictly define it to allow only the owner to be able to call that function. So when we do this now, we should no longer be getting that error. Our test should be passing. Now that's good. So, but we've not completed the test, right? We need an assertion that checks something. So we want to assert that calling decrease counter when we call decrease counter, we can get the counter. But wait, failures. Okay, yes. Our test did not pass. I wasn't expecting it to pass. That's why I came to check it again. So now, if you remember when we were defining our contract, right, we added another constraint for the decrease counter. We said the counter cannot be less than 0, right? So we cannot decrease the counter if the counter is 0. right? And another constraint we added is the amount the amount we're decreasing the counter by must not be greater than whatever the value the counter is, right? So now right here we're trying to decrease the counter by 2, and when we deployed our counter, because we're still calling this function here, so it's still going to deploy our counter with what? 0. So when we deploy our counter with 0 here and we try to decrease it, it's going to throw that error of saying counter cannot be less than 0. So before we can decrease the counter, we have to call the increase counter function, and we are calling that also cheating the contract, right? So we have ownership access, and then we can now decrease the counter, right? So we have to increase it first and then decrease the counter. So now the counter is no longer 0. But let me do something. Let me increase it by 1. Now the counter is no longer 0, right? But we're still expecting another error. I can comment that out. The second error we're expecting is amount is greater than counter. So the amount 2 is greater than counter 1. So you can see the failure data, right? Is according to whatever value we passed, right? So you can see is a custom failure data. If you pass 3, right, it's going to say amount 3 is greater than counter 1, right? And if you go back to our contract here, you can see I wrote an assert, right? And I passed a custom data. So it asserts this comparison, right? That the current counter is greater than the amount, else it's going to throw this error. And what I did, I passed a curly braces, right? And what is going to be inside this first curly brace is going to be amount, the next parameter we're passing. So the amount, whatever this amount is greater than counter whatever this value is. Right? So this is another use case of the custom failure message, right? Do you understand? So with the assertion now, so whatever amount we pass here is going to be part of the failure message, and whatever the counter value is going to be part of failure message. So that's why we're getting amount 3 is greater than 1. So we cannot subtract, so we cannot remove 3 from our counter when our counter is 1. So we need our counter to be greater than that or equals to that. So if we're increasing our counter by 3 from 0, our counter is now going to be 3, and now we can decrease the counter 3 times, right? Like that. So if we run the test again, amount counter is greater than, so amount 3 is greater than counter 3. So that's not what we want. So we can go back to the contract and change the assertion here. So the error is from the assertion. So we want to assert that the amount is greater than or equals to, right? Greater than or equals to. So it can minus 3 from 3. Right. So if we run that again, that should pass. So now we can see our 3 tests are passing, right? 0 failed. Do you understand what we have done so far? I'm not getting any reaction. Is anybody following? I'll stop teaching if there's nobody responding. Is anybody following? Is anybody in the class? So you might not be able to recreate every line of code I've made here, right? But as far as you're getting the key concept, I can provide the code for you right? Even after the class, you can go into it or you can watch the videos. But the main thing you need to get right now is the concept. So now we've written the setup, we've increased and decreased the counter. The last thing we want to do, want to write an assertion that asserts that now the counter should be 0 once again, because we have decreased the counter back to 0. So get count, assert that get counter equals to 0. Else, we'll now throw our error, counter not 0. Right, add a semicolon. So now we have an assertion. The test should still pass. That's good. So now we have that going. We are doing our basic integration test. So the next thing I want to touch on is another advanced concept using SNforge, which is ignoring tests. So we can choose to ignore some tests, right? For example, we are writing a new test, all right, and we've not completed the logic of the test, and we want to run our test and expect it to pass, right? So let me just start writing a new test, or let me just copy this, right? And there's probably a bug somewhere in this code. Let me just leave it like this. I don't know. Can we do that? So you can see it's throwing an error, right? So all we can do, we can ignore, we can add an ignore attribute, right? We can add an ignore attribute to this particular test. And what that tells the compiler to do, basically tells the compiler to not run the test, or not run this, ignore only this particular test. So when I do start test, I hope this works. But it will not be able to compile. It's not be able to compile, yeah. Not be able to compile because this is a syntax error, not a logic error or something. So let me just return this code back, and let me just see, let me just add the ignore to this attribute to this. Right. And now I run scrap test again. We'll see that that test will be ignored. So now running 3 tests, right? Ignore decrease counter. So it's ignoring decrease counter test. It's not running that test, but it's running initial counter and increase counter test. So you can now see here the summary: 2 passed, 0 failed, 1 ignored, 0 filtered out. Right. So now I'll be able to ignore that particular test from running. Do you understand that? Do we understand how we're able to ignore that particular test? So yeah, that's just a simple way to ignore a test. Just add the ignore attribute to the test, and automatically the test will be ignored. Now another thing we'll touch on is filtering tests, right? So we can have multiple tests, right? As many tests as possible. I said some cases in some code bases you see over 400 tests, right? Like in one file which is one crate can have like 100 tests. Then you can now have like 10 to 20 more test files, right, with different tests. Now, when you want to run that kind of test package, it usually take a lot of time. So what you can do something called filtering tests to filter the particular test you want to run. Right, to filter the particular, and this is usually, we can usually do this with SNforge. But basically, we also know that scab test uses SNforge behind the scenes, right? So whenever you're running scab test, it basically runs SNforge, but you can also still run SNforge by yourself. So SNforge tests, doing SNforge test is the same thing as doing scab test, right? So if you do SNforge test, then the name of the particular test you want to run, let me say test initial counter, right? And then I pass it like this. is going to look for the test to that particular name and run only that test. Right? You can see it's running only that test function, right? Running collected one test, it collected only the test that matches this name, that matches this function name. Do you understand? And then it's running 0 tests from source, which is supposed to be unit test, and 1 test from integration test, which is only running what initial counter test. So 1 passed, 0 failed, 0 ignored, 2 filtered out. So it's filtering out the remaining tests, this and this, and is running only this test. Running only this. So it's filtering the two others out. Do you understand that about filtering tests? So we can filter the tests by the test name. If you want to do that with scab, right? We can really do this by just saying scab test. Then we pass this 2 dash, right? We pass those 2 dash. And what those 2 dash means, it just basically tells tells scab, right? Is a separator. It just basically tells scab that this what we are passing here is not for scab, it's for the underlying runner, the underlying test runner, which is SNforge. So it's basically saying that because scab doesn't have the power to filter tests, with SNforge behind it, that has the power to filter tests. So if we do this, it can work just like it works perfectly because it's using scab test behind the scene. But in some cases, some kind of filtering you do, right, will not might not work with scab test. Let's say you want to skip a particular test, right? Another way can filter the test we want to do is by using skip keyword in SNforge, the skip feature or the skip flag. So we can skip a particular test. So what the skip does, it basically runs other tests and skip that particular test. So skip test initial counter. So it will skip only that test and run the other test. Right. So you can see it's running test increase counter, test decrease counter, one filtered out, which is the test initial counter. Do you get that? So sometimes you might be running some. Why I was bringing up the what do you call it? The separator is for passing flags and also for running commands to SNforge. Right. So basically, we have looked at 2 ways to filter tests, right? Is by passing the particular name of the test function. So it will filter every single one out and run only that particular test. Another way is by skipping a particular test and running every other test, right? So we can skip as many tests. We can say skip that test, skip test increase counter also. So now it's going to, sorry, I pasted it wrongly. So let's just skip this and skip test decrease counter. So now it's going to run only test decrease counter. Collected only 1 test and skipped the 2 out. You understand that? So that's basically how to do it. And another thing we can do, we can also, in a case where we have several test files, right? Do Cairo handles each test file as a crate, right? Similar to how it handles every function inside this module as one crate for the library, right? For the lib.cairo. In every test, when you add another test, let's say test, testing, maybe we have a calculator contract, test calculator.cairo. So it's to run particular files, right? To run tests in a particular file, you can basically just do the same thing. Test and the name of the file, test contract. So it's going to run only the test inside this particular test contract. Oh, we don't have any file named test contract. Scrap test test counter. So it's going to run only the particular test inside this test counter file, right? But if it runs cap tests generally, it's going to run all the tests inside this file, and unit test, right? So I've given you different ways to filter out particular tests that I want to run, which is by filtering them by the files, right? By filtering them using skip, by filtering them using the particular function name that I want to test, right? I think that's clear. So we've covered another concept. We've covered ignoring tests. We've covered filtering tests. We've covered custom failure messages. One more thing we're going to cover. I think we're behind. We're out of time. So let's just do a little bit of testing loops. Right. Let's see if we can do that. I don't know if there's any scenario that involves testing loops. Right. But I don't think we have that scenario. We don't have any loop function in our code here, right? So what that is really useful, when we are running these programs on the blockchain, it takes gas. Gas is a measurement of the computation that it takes to run a particular function or program on the blockchain. That's the simplest way I can explain what gas is. So running things like loops, all right, it takes a lot of computation, right? So for every functions or recursive functions, there's a way we can test to ensure that the function is not too heavy, and that's by using the attribute called available gas. So we can just pass and say, okay, for this function, the amount of gas we want to use for this function is, let's say, 2000, right? So once the gas required for this function exceeds 2000, is going to be insufficient gas. So we are not going to complete this function. So, but in this case, it doesn't really matter because it's using a little amount of gas. If you look at the gas here, you can see 705,420 gas. You can see there is little amount of gas, but in very expensive functions, it usually involves using a lot of gas, right? So we usually use this to ensure that we're not the gas that is required for that function. So if we leave this the way it is now, you can see we have only just 20,000 gas here, and we're trying to run a function that is costing about 70 to 90, 700,000 gas upward. So if we just say, let's run carb test, it's going to give us insufficient gas when running that. You can see test cost exceeded the available gas, right? So because of these tests, we can ensure that our functions are cost effective, that they are not too bulky, right? They don't use more computation than we expect it to use. So this is a way of testing loops, right? To ensure that the loops are not so expensive. But yes, I just did this to basically cover up with the concepts that we plan to tackle today. So today we've touched a lot of concepts, a lot of things in integration testing, and even by Friday, we'll touch a few more things like testing events and then give you assignments. I don't think we have so much to do in tests again. We might do first testing and others according to what we have for that session. But basically, today we went through the contracts. We talked a little bit about the file system. We talked about SNforge, SNcast, Starknet Foundry in general. we declared our contract, we passed the constructor data, we deployed the contract, right? Then we wrote tests that test different functions exposed by our contract. And we did that using our dispatcher, right? And I said as before that dispatcher is exposed by the trait. So whatever is in your trait of the contract is going to be provided to you in the dispatcher. All right. So if you have any question, you can go ahead and ask them now. We also talked about custom error messages, which is did by passing the values into parentheses placeholders. Yeah, and that's that about that. So if you have any questions, you can go ahead and ask before we end this class today. Is there any question? Any question? I'm not getting any response. Does that mean we all followed and we understood? Okay. So if we all understood, I'm going to be asking my question. All right. I'm going to be asking a simple question just to know we understood a little bit of the concept of what question would I ask? Okay. So what was the dispatcher basically? What was the dispatcher? What idea do you have on dispatchers? I need somebody to answer that before we call this a close. Anybody? Just tell me what's the idea you have or what a dispatcher is. I can always correct
Okay.
you.
I think, from my own understanding, dispatcher is like helping to call the not just the contract address, but the contracts in itself, like the contracts.
Yes. Yes, basically, yeah. You're very correct. So basically, the dispatcher gives you access to the contract itself and the contract functions, the functions in the contract, right? So it's a way to interact with contract. So even not just for your testing, all right? When two contracts are interacting with each other, they interact with each other using the dispatcher, all right? The dispatcher exposes a function in a particular contract for another contract, right? So not just in our tests, we can always use dispatcher, right? So that's basically what a dispatcher is. It makes the functions exposed by the ABI, right, available for us to use in our tests and other scenarios. So basically, that will be all for tonight. I believe if you have any other question, you can leave it out in the group chat. And please remind me to make this code available for you if you need it. I can always push it to GitHub and yeah, share it with you. So
Post the slide to Instagram, make it available.
the slides, right?
Uh,
Yeah, just leave a comment on the group chat and I'll do that. So thank you for joining. Do have a nice day.